Hey everybody, this is Mr. Longo, and this video is going to cover how you solve trig equations. Now, the thing about trig equations is we can give you intervals that you are allowed to solve in between. Sometimes you can have infinite answers. Sometimes only the answers within a certain range are allowed. So to do that, we need to talk about interval notation. Now, parentheses means it's not included. So this A, comma B in parentheses means that your answer has to be in between the values of A and B, not including A or B. Now a bracket, a square bracket, means you can include it. So this notation means that it has to be greater than A, and it has to be less than or equal to B. So in that one, you can be equal to B. This one, if you have two brackets, that means both are allowed to be in your answer. So it could be in between A and B and including A and B. So square bracket means included, and a regular parenthesis means not included, but after that or before it. And of course, infinity is all real numbers. So anything from negative infinity to positive infinity means all real numbers are allowed. Okay? Also, when solving, if we're solving for theta, we are in degrees. If we are solving for x, it means we're in radians. All right? So that's just what we're going to work with. So let's go do some practice problems. You're going to obviously need a calculator to do this if you don't have the unit circle memorized in your head, which is totally fine. Use your calculator if you need it. So what we're going to do here is we're going to solve algebraically. Now I want you to note the notation for this is we are going to be allowed to be between 0 and 360, including 0 and 360. So the first step is to solve for theta. So this is just like any other algebra equation where we have to get theta by itself. So our first step is to add the square root of 3 to both sides. So that's going to leave us with 3 tangent of theta is equal to the square root of 3. And now to get tangent of theta by itself, we have to divide both sides by 3. So you now have tangent of theta is equal to the square root of 3 over 3. Now, theta is degrees, so where is theta going to give you the square root of 3 over 3 for tangent? And the answer to that question is 30 degrees. Now, like I said, you can just type second tangent root 3 over 3 in your graphing calculator, and you will get 30 degrees. But we need to list all answers between 0 and 360. So the trick for this part is to draw the circle. And we know that our first answer is 30 degrees. So now you need to think of where else is tangent going to give you a positive square root of 3 over 3. Now you have to remember it's a 30-degree reference angle. And tangent is also positive in quadrant 3. So 30 degrees past 180 would give you 210 degrees. So theta is equal to 30 degrees and 210 degrees. So make sure you draw the circle because it will be very helpful to you. Now there's a way you can check. You can check your answer by now just typing the tangent of 30 and the tangent of 210 in your calculator and see that they give you the same decimal. If they give you the same decimal, you at least found the other angle correctly. But the first one is done in the calculator and you should have no issues with that. Okay? Next example. Again, first thing we have to do is get all of this by itself or cosine by itself. And we're going to go from 0 to 360 again. So step 1 is divide both sides by 2 because we have to get cosine by itself because of the parentheses. So we're going to have the cosine of theta plus 35 equal to 1/2. Now this is the part that's going to be a little bit different. So now we have to do inverse cosine of both sides. And if it helps you to remember it, you can actually say cosine -1 to both sides. And inverse cosine, that gives you 1/2. So theta, to give you 1/2, is going to be 60 degrees. And of course, you can just type second cosine of 1/2 in your graphing calculator, and it will tell you that your first answer is 60 degrees. So we're going to go over here and draw this. And your first answer is 60 degrees. Now your second answer, it's cosine. It's positive 1/2. So remember, cosine is positive when x is positive. So our other angle is going to be here. We're not going to use -60 because we have to be between 0 and 360. So if we were to go all the way around, our 60-degree reference angle is going to tell us that this angle is 300. So inverse cosine of 1/2 is going to give us 60 degrees and 300 degrees. But that is what theta plus 35 is equal to because of those parentheses. So theta plus 35 is equal to 60 and 300. So now you have to subtract 35 from both of those, and you will have theta is equal to 25 degrees and 265 degrees. Okay? So if, remember, you have parentheses here. So when you take inverse cosine of 1/2, you have to remember that's where you get your two angles. Then you have to subtract your 35. Okay? There's two more examples. If you feel comfortable enough, pause the video now and just give those two a try on your own. Once you're ready, click play. So this example, we are actually solving for x, which means we're thinking in terms of radians. And if you didn't remember that, of course, our constraints are going to narrow that down for you. So the first thing we're going to need to do here is subtract sine x to the left side. And you'll see as soon as we do it y. But we have cosine of x, sine x minus sine x is equal to 0. Because now we can factor out a sine x, leaving us with cosine x minus 1. And that's equal to 0. So this is just solving. This is just solving by factoring. We factored out a GCF. So once you used to factor and you had like x times x minus 5, you would separate them. So we're going to separate this one too. We're going to have sine x is equal to 0, and we're going to have cosine x minus 1 is equal to 0. So this has the potential to get crazy, but we'll see what happens. We're going to go draw a little circle now. So where is sine x equal to 0? So 0 is our y value. So sine x is equal to 0 at 0 and pi. And now we have to work with cosine. So we have cosine of x is equal to 1. Now cosine is equal to 1 only at 0. So that one right there is a little crazy. Now I put it off to the side just so you can see that we have two different answers. So now is where the tricky part comes in. Your answer must be somewhere from -pi to 0. So that means -pi is a potential answer, but 0 is not. So if we look between -pi and 0, the only answer that shows up that we are allowed to have is -pi. So x is equal to -pi. We are not allowed to use 0 because it's not in the range. Okay? Last example. Last example here, again, we're going to be solving for theta, so we got to switch our minds back into degree mode. First thing you're going to want to do is divide both sides by 4. And that's going to give us cosine squared theta is equal to 3/4. And we need to get rid of the squared. So just like we used to do back in the day, you get rid of square by square rooting both sides. And that's going to leave you with cosine of theta is equal to plus or minus the square root of 3/2. So now we have two answers to think about. So we have the cosine of theta equal to the square root of 3/2. And we have the cosine of theta equal to the negative square root of 3/2. And we need to include all of those possibilities. So we're going back to our circle. And the first part, I always think in terms of what makes the most sense. So cosine of theta is equal to the square root of 3/2 when our x value is the square root of 3/2, which means our first answer for this guy is 30 degrees. Okay, so our first answer for this is 30 degrees. But also, cosine is also positive over here because cosine is our x value, which in this case would be 330 degrees. Now I want you to think about that 330 degrees for just a second. We have to be between negative 180 and 180. So instead of 330 degrees, you're going to want to think about that guy in terms of negative 30 degrees. Okay, and now we still have to go use cosine of theta is equal to negative square root of 3/2. So if we're at negative square root of 3/2, that's when x is negative, so cosine is over here. And that is when we have a theta value of 30 degrees away from 180, so that's 150 degrees. So our first answer is 150 degrees. But cosine is also negative down here in quadrant 3 as well, which of course is a 30-degree reference angle past 180, giving us 210, but 210 is too big, so now we have to go from the negative direction, and we get negative 150 degrees. Okay, so now that we have everything together, we just have to make sure that all of our values fit in between negative 180 and 180. So basically what that meant is that we were allowed to start at negative 180 degrees and go all the way around the circle, include anything that goes up to positive 180 degrees. So that's where that all came from. So you just have to be very careful with your constraints. So your final answer is actually all four. So theta is equal to plus or minus 30 degrees and plus or minus 150 degrees. So as you can see, you can have four answers, you can have one answer, two answers, it's all over the place. You just have to make sure you're plotting all of your answers so you can see which ones fit into your constraints. All right, so that's your first video on solving. We're going to do one more where they get a little bit more complicated a little later. This is Longo and I'm out. See you, bye.